Hello class. In this video, we talk about subsets. Two important symbols. Let's say we have two sets, A and B. If we have this notation, connect the two sets, then we say set A is a subset of set B. Subset has two cases. The first case, A is a proper subset. Second case, A and B equal to each other. All right, so when we see A is a subset of B, that means either A is a proper subset of B or A and B are equal to each other. All right, then what is the definition of subset? The formal definition for subset means if A is a subset of B, that means all the members in A are all members in B as well. One more time. A is a subset of B means all the elements in A all belong to set B as well. So when two sets are equal to each other, we could say A is a subset of B as well because all the members in A also belong to B. And another case, when A is a proper subset of B, that means A is a proper subset of B means A is a subset of B, but A is not equal to B. Does that make sense? A is a proper subset in B of B means A is a subset of B, but A and B are not equal to each other. That means if we use Venn diagram, the Venn diagram is a very efficient tool to study set theory, VENN. Then we can use this relationship to represent proper subset. Proper subset, it means set A completely fall inside set B, and the circle of A is smaller than circle of B. And A equal B, that means they overlapping. A equal B. Does that make sense? Yeah, one more time. A is a subset of B, means all the elements in set A are also elements of set B. All the elements in set A are also elements in set B. If A is a subset of B, but A and B are not equal to each other, then we say A is a proper subset of B. In that case, the circle of A is smaller than the circle of B. B has more elements than set A. Let's look at examples. Choose one of the two symbols to connect the given two sets. One set on the left has three elements, 94, 0, 4. The set on the right has 1, 2, 3, 4, 5, 6 elements. And obviously, we should put not a subset symbol to connect the two sets. Not a subset. Why? Because 0 is not an element of the set on the right hand side. In order to make the subset relationship hold, the set on the left, all the elements in set A have to belong to set B as well. But here 0 is not an element, so it's not a subset. And the second one, On the left side, we have X. X is a letter in the word proof, Proof. So basically, the set on the left contains 5 letters. Actually 1, 2, 3, 4. 4 letters, because 2 O's, when the element repeats itself, we only count it once. So Prof, that is the set on the left side. And the set on the right side contains all the letters in word roof. So ROF. We should put not a subset. In fact, the set to the right is a subset of the set on the left. The other way around. Next question, determine whether subset, proper subset, or both can be placed in each blank to form a true statement. As we can see, this set and this set, they have exactly the same elements, 5 elements. So those 2 sets are equal to each other. When they are equal to each other, they are subsets of each other as well. So we can enter this subset notation. We can only use that, not both. We can only use the subset notation. Next question. The set on the left, X is a person who lives in San Francisco. The set on the right contains all the people who live in California. So what do you think? We can use both, right? We can use both. People who live in San Francisco also live in California. But people live in California not necessarily live in San Francisco. So this is a proper subset. But we could also use a subset notation to connect the 2 sets. So basically, we could use both. If you see some problem like that in MATLAB Math, knowing you should choose both, because both of them would make the statement as true. Determine whether each statement is true or false. If the statement is false, explain why. The first statement is true, because Canada is an element of the set on the right side. We talked about element is an element yesterday, right? Yeah. And the second statement is false, because this is an element. We do not really use subset notation to connect an element and a set. It's a misuse, is abuse of the notation. Yeah, again, this subset notation can only connect the 2 sets, not element and a set. Next question. If a set contains n elements, how many distinct, different subsets can be formed? List all the subsets of the given set. We have a theorem here, all right? Yeah. So if the cardinal number of a set, let's say the set A, is n, then A has exactly 2 to the power of n different or distinct subsets, and 2 to the power of n minus 1, 1 less than that many number different proper subsets, right? Yeah. So we are going to prove this theorem. Yeah, let's take time to prove that first, and then we use it. In order to explain why, if a set has n elements, then it has 2 to the power of n distinct subsets. And we want to start from the fundamental counting principle, okay? So we want to start from the famous fundamental counting principle. And I want you to please connect fundamental counting principle with one simple example. Whenever you think about fundamental counting principle, what is it? You think about this example and you know what is it. Let's say we have 3 locations A, B, C, and your task here is to drive from A to C, passing through B. Suppose from A to B we have 2 routes. From B to C we have 3 different routes. Now how many different routes do you have from A to C passing through B? Yeah, again, from A to B we have 2 different routes. From B to C we have 3 different routes. Then from A to C passing through B, how many different routes do we have? Please don't tell me 5. Pause the video and think or count. We should have 6 different routes, all right? Yeah, we multiply the 2 numbers. There's another name for fundamental counting principle. It's called the multiplication rule. Because we are using multiplication, we are not using adding. We multiply the 2 numbers. If we have a 2-part task, like this example, the task has 2 parts. The first part has 2 different ways to complete it. The second part has 3 different ways to complete it. Then we have 2 times 3. We are going to multiply the 2 numbers. 6 different methods, different ways to complete the whole task. That is so-called the fundamental counting principle. All right. Another example, let's say you are going to go to a party. You need to choose a top. You need to choose a bottom, like a skirt or pants, and you need to choose the shoes, right? Yeah. Let's say you have 4 different tops, you have 3 different bottoms, you have 2 different pairs of shoes. Now, how many different ways you can dress yourself? You don't add the 3 numbers, okay? You multiply the 3 numbers. 4 times 3 times 2. You have 24 different ways to dress yourself for the party. That is so-called the fundamental counting principle. Why we need to know fundamental counting principle to prove this conclusion. Let me explain, all right? Yeah. Suppose we have a set A. It has 3 different elements, A, B, C, all right? We want to figure out how many different subsets that a set A has. Yeah, how do we do that? In order to make a subset, let's say subset of A. Subset of A is also a set, right? Yeah. Subset of A is also a set whose elements come from set A, right? So set A has 3 elements. Now we are going to make a decision. We are going to form a subset of A. We're going to make a decision. The decision, you can see the decision as a task. And in this case, the decision has 3 parts. Why has 3 parts? The first part we need to determine, are we going to include A or exclude A in a subset? We either use A in a subset or not use A in a subset, right? So we have 2 ways to do that. The first part of the task, we have 2 ways to determine, are we going to use the first element or not? All right, so 2. And the second part or second step is to determine, are we going to use the second element B or not? We either use it or not use it, right? So we have 2 different ways to do that. Same with the third element, the last element. We either use C in the subset or not use C in a subset. So we have 2 different ways to complete the third part. Multiply them together based on the fundamental counting principle. 2 times 2 times 2 is 8. Well, we can write that as 2 to the power of 3. Right? 3 is the cardinality of set A. Right? 3 is the cardinality of set A. So we have 8 different ways. 8 different ways to form a subset for set A. In other words, set A, which has 3 elements, has 2 to the power 3, which is 8 distinct subsets. Well, you can change the number of change the cardinality of set A. If we write the cardinality as n, then we have n parts when we make the decision, right? The first element include or not, second element include or not, and the last element we include or not. We have n elements to determine, right? So that's the reason we have 2 to the power of n different ways to form a subset for set A. 2 to the power of n is the number of different subsets for a set A if it has n elements. Okay, so this table actually shows you the 8 different subsets. If the subset only contains one element, we have this, right? 3 subsets. If the subset contains 2 elements, then we have this, 3 subsets. If the subset contains 3 elements, then the subset is the same with the given set. And the subset could contain nothing, right? So yeah, empty set. The empty set is also a subset. Empty set actually is a subset of any set. 8 different subsets. All right, I hope after the explanation you have a better understanding and impression about this formula. You need to remember this formula, okay? You need to remember the formula. If set A has n elements, then it has 2 to the power of n distinct subsets. The number of a proper subset is 1 less than that. Proper subset, then just do not include the set itself, right? Like in this case, you just do not include this one. And you have 7 proper subsets. All right, let's look at examples. Calculate the number of subsets and the number of proper subsets for the set. The set is given in the set builder notation. The set includes all the US coin worth less than $1. So what I know is it could be penny, right? Could be a nickel, could be a dime, could be a quarter, could be a $50. Even I didn't see any. I never seen a $50 would look like, but there is a $50 coin. You can Wikipedia or Google. So there are how many elements in this set? One, two, three, four, 5. Yeah, the cardinality number is 5, right? Yeah, 1, 2, 3, 4, 5. The set has 5 different elements. Then how many subsets this set has? 2 to the power of n, 2 to the power of 5, 32, right? And how many different proper subset? -1, 31. Last example. A cheese pizza can be ordered with some, all, or none of the following set of toppings. Let's see what topping options do we have. Beef, ham, mushrooms, sausage, green pepper, pepperoni, olives, prosciutto, onion. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the set of toppings has 9 elements. Let me count it one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Okay. Now how many different variations are available for ordering a pizza? So this actually is to ordering a pizza by choosing the toppings. Actually is a process of forming a subset of the set, the given set. So we have, by the formula we have just proved, there are 2 to the power of n, this many subsets, right? So let's use a calculator to figure out what is 2 to the power of 9. 2 to the power of 9 equals 512. That many different ways to order the pizza. That's the number of subsets of the set of toppings. Okay, that's everything about subsets. Please repeat the video. As I said, when I teach a face-to-face class, I am a lot slower. But when I'm just recording the class, I tend to go faster. But because you can always pause and repeat a part, right? Yeah. And you can work on your homework 2.2 now. If you have any questions, please feel free to email me. I'll see you tomorrow. Bye.